Four distinct real numbers, a, b, c, and d, are used to define four pairs. AB, BC, CD, and DA. The quadrilateral capitals ABCD has all four sides the same length, if and only if one of these relations holds, or for no values of ABCD. I wonder if it could be for no values. The quadrilateral has all four sides the same length. Okay, so I was tempted at first to sketch a diagram. To see what would happen. But I think instead what I'll do is just write out some distance formulas and see what happens. I mean, all of the options given to us are somewhat algebraic in the way they're written. So maybe if I write some algebraic relations, that might help. Okay, so the distance between B and A, B and A squared plus C minus B squared. This has to equal C minus B squared plus D minus C squared, which has to equal D minus C squared A minus D squared, which has to equal A minus D squared plus A minus B squared. Well, if I take just the first one, I notice that this is equivalent to B minus A squared is equal to D minus C squared. Because I have a C minus B squared that cancels on each side. And if I look at the second and third lengths, I also have a cancellation. I need C minus B squared to be equal to A minus D squared. And we get relations for all of these. But then when I look at, okay, so I get a relation from there. I get another relation from there. But the relation I get from here, A minus D cancels. So I get A minus B squared equals D minus C squared, which is the same as this. So I have these relations. What if I compare the first and third and the second and fourth? What do we get from that? I feel like I can rule out the first three options. Right, option A is this. but there are other there's another requirement that we need here. But option B, sorry, this is the same as option C, but that doesn't guarantee that all four sides are the same, because we need that to be satisfied. What happens if I make some substitutions? So I have this third equation. I know b minus a squared is d minus c squared. So in fact, if I enforce these two, that already guarantees this is true. I don't like doing guess and check work, or I don't like individually invalidating some of the options here, just because I like to show a more well-structured thought process of how to actually solve problems rather than just taking multiple choice answers and subbing them in. But I think I'm not sure how I might manipulate these to get one of the options given or to rule them out. What I think I might do is test A equals 1, B equals 2, C equals 3, and D is equal to 4. Does this even work? Does it even satisfy D? 1 minus 2. I don't think that works. So we have, hold on. Let's go A is equal to 4, B is equal to 3, C is equal to 1, and D is equal to 2. So then I have A minus B plus C minus D is equal to 4 minus 3 plus 1 minus 2 is equal to 0. And let's see if this works. Well, AB squared is B minus A squared plus C minus B squared, which is 1 plus C minus B, 1 plus 4, which is equal to 5. Okay, let's compute BC squared. C minus B squared plus D minus C squared. C minus B, D minus C. Yeah. C minus B, that's the squares again, equal to 4. D minus C is 5. Okay, so that works. CD squared. So D minus C squared plus A minus D squared. D minus C squared is 1. A minus D squared is again 4. And let's compute dA squared. D minus A squared plus A minus B squared. D minus A squared is 4. A minus B. Interesting. I am I'm not sure why this works. If I have chosen, I don't completely, let's do this with different numbers. Let's let A be equal to 8, B is 3. So that's a difference of 5. So I need this to be 6. A minus B, 8 minus 3, plus 1 minus 6 is equal to 0. And let's just recompute all of these. B minus A squared is 25. C minus B squared, so 29. C minus B, D minus C, D minus C, A minus D. What? I don't understand why this works, but it seems to be working. D minus A. So my answer is going to be D. That we need A minus B plus C minus D to equal 0. But I'm not really quite sure. Well, I guess, okay. I guess we can rearrange it to say A minus B is equal to D minus C, which implies, that implies this. But we can also rearrange it to A minus D is equal to B minus C, which implies this. Yeah, I feel like I don't have a full understanding of why this is true, but given the options we have available, this has to be the answer. So I'll leave it at that. That'll be my final answer, but if I have a mistake, I'll let you know. Thanks for watching.